we're going to review the transformations of functions. And let's start off with a horizontal shift. I'm actually going to start with putting the basic graph of a parabola. In fact, actually, let's review the fact that we can use this I think I'll go up here for this. We can use this with various types of functions. And the types of functions that we usually use as basic examples is one of these three. A quadratic, an absolute value, or a square root function. So I'm going to use as examples for this one a quadratic, but the same type of thing can be done with these other two. All right, so here for a horizontal shift, well, the parent function for a quadratic is y equals x squared. And I'm going to put the basic points for that and put dashes to show where that is. I'm actually going to do that for each one of these little graphs as we go, because each one of them will show the differences. So what happens in a horizontal shift is you get y equals something like this. Inside the parentheses, or rather with the x, there's a change. There's adding or subtracting a number. Okay. And what this means is left 3 units. Plus is left, and minus is moving right. So that means everything here moves over 3. The vertex, the other 2 points here, and the 2 points up here. So this one is our function. In fact, I think I'm going to change this from y to f of x, and we'll call this one g of x. So this is g of x, and the basic one is f of x. Now let's take a look at the same thing with a vertical shift. Okay, so this is f of x, and g of x is going to be x squared plus 3. Now the 3 is on the outside of it, and what that means is that it will go up 3, or it could go down 3. So in this case, it's going up 3. Every single point on the graph goes up 3, and so that'll be g of x. Now, we could have another one, h of x, squared minus 3, and this one goes down. So one of the things that you can see is that the change of sign here, the change of sign makes you go opposite of what you would think. So a positive makes you go to the left when you would think you're going into the negatives, but it's opposite of that. Here, a positive does mean going up to the positive, more positive numbers, or negative means going down towards the negatives. So for vertical shifts, it's the same. Okay, now a reflection over the x-axis. So let's put the parent function in here. And that's f of x. Now, the difference here is x squared, is that in this case, we'll do for g of x a negative x squared. And that would mean going down like this. So that's g of x. And that's actually because it's the same as -1 times x squared. So that negative actually means a coefficient of -1. Okay, just another way of showing it. We don't usually show the actual 1. Okay, now reflecting over the y-axis, that one up. This is not very common, but it's good for you to see a difference on it. In this case, we still have f of x as the basic x squared. Now, in this case, g of x will be negative x squared. The thing about this is that you can't tell the difference right now. So a point here would go over to here, and it's the same as that point that's there. A point that's here would go over to here because it's going over the y-axis, ends up in that arm. So the two arms do switch. You just can't tell from here. It would be if there's a different place. So, whoops. So if we had a parabola here, then it would switch to over here. Okay, so that would change to there. I'll call this one R of x and S of x. So the R of x in this case is, oh yeah, I can write that up. It's 1, 2, 3, 4. So that's x minus 4 squared. And S of x is negative x minus 4. Plus 4 minus 4. I think it's, in this case, it's just the x. So again, it's that change there that switches it, flips it over the y-axis. Now a stretch. Here is the parent function. And here we have, for stretch y, let's put f of x equals x squared. Now for g of x, I'm going to do a stretch, and that means a number greater than 1 in front of the x squared. So for stretch, a is greater than 1. And that means that this goes up much faster, starts at the same spot, and goes up like this. Now, a shrink is different. In fact, let's do the same thing here. F of x equals x squared. G of x, let's do 1/4 x squared. And what happens here is that the a number, the number in front of the x squared, is between 0 and 1. In other words, it's a fraction of decimal that's small below 1. But not negative, because a negative would mean doing a reflection. So what we do here, here's the parent function. And this one is going to go out where, let's see, I believe it's going to be this point for it. If I put 2 in here, 2 squared is 4. 4 times a fourth is 1. So 2 and 1 were here. So that means that this is approximately what the 1 looks like if it's 1/4. It spreads out and opens up more. So the stretch one, like pulling a rubber band, closes the inside of it more. In a shrink, it's like opening up, like a flower petals opening up. Right? And the difference is whether you have greater than 1 or less than 1 for the a value before the x squared. So those show the basic types of transformations. 2 of them are shifts, going sideways or up and down. 2 of them are reflections over the x-axis and y-axis. The reflection over the x-axis is far more common. And then 2 of them are stretching or shrinking based upon whether the a is greater than 1 or between 0 and 1. Now, let's take a look at dealing with this by taking one of these, this time in absolute value, and let's do these things. Let's shift it down 5 units. So that is going to mean the absolute value of x, and since it's down, it's going down -5, and that's on the outside of it. Shifting left 4 units, well, it's going towards the negatives, which means we're going to do +4, but it's going to be inside it. Stretching by a factor of 3, okay, would be, stretching means multiplying by 3. So that's going to be y equals 3 times the absolute value of the x. Reflecting over the x-axis, reflecting means simply using a negative. Now let's actually put all these together, all four transformations. So the inside part is x plus 4. Then we're going to have a negative 5 on the outside and a 3 in front and a negative in front. So we're going to put all of these together. And that's all four transformations. Now there's just enough room here for one more thing. And actually I'll do this as another page here. Okay. And so let's do a part 3. Given y equals negative 5, this time we'll do a square root function, x minus 2 plus 7. Identify the transformations. The order of these don't really matter. Let's just start off with the first thing that we see. So we see here a negative, so it means it's going to reflect over the x-axis. We often do that last, but I'm just going to go in order of these. 5 means a stretch. By a factor of 5, because it's multiplying and factoring, or a factor is something you multiply with. Factor of 5. Next, we have this negative 2, which means instead of going to the left towards the negative, we're going right to the positives. And so it's moving right, moves right 2 units. And finally is plus 7. So it moves up 7 units. Okay. And actually, instead of the word move, shift is probably better, but move works, it makes sense, but I'm going to change that to shift on my paper here. So shifts right 2 units, shifts up 7 units. So in this problem, you take each of the types of transformations and make the equation. Here you take the equation and pull out from it the types of transformations. I hope that helps with reviewing transformations for functions. Thank you for watching and listening.